Welcome to another learning session. I need to talk about a topic. You're going to guess what we are going to learn today. Solve the connection that is going to be shown on your screen. Yeah.
Yes, exactly. We're going to discuss on the topic photodiode. The learning objectives of this session would be 1. To comprehend the working principles of photodiode, and 2. To know the applications of the device in real world. Before getting into the further details, we'll see the agenda of the session. We'll start off with the principle, then we'll know the schematic representation of photodiode, and we will try to recollect the basic concepts that will rightly fit in for this topic. Then we will try to understand the working principle of photodiode under two cases. One, when there is presence of light, and two, when light is absent. To boot, we will try to understand the characteristic curve from the explanation of working principle. We'll list down few applications, very important applications of photodiode. We'll draw the curtains after we finish the advantages and disadvantages of photodiode. First, we will understand the principle. முதல்ல அந்த photodiode ரெண்டா பிரிப்போம். We will split the word photodiode as photo plus diode. Photo is light, diode is a two-terminal device. So, photodiode is a two-terminal device that will accept light as input. So, light falls on the device, light falls on the diode. So, it gets input as light and it will convert light into electrical energy. So, photodiode is a device which can detect light. Photodiode is otherwise called as, sometimes they are called as photodetectors or photosensors, and mainly they are operated in reverse bias. To summarize, photodiode is a two-terminal device that operates in reverse bias and converts light energy into electrical energy or electric current. Next, we'll move on to the circuit symbol representation. From the screen, you can understand there are two arrows pointing towards the diode or coming inside the diode. That represents the light rays falling on it. A diode with two arrows pointing towards it form the circuit symbol for a photodiode. To understand the working principle of the photodiode in detail, we will try to recollect some of the known basics that rightly fit in for this topic. First is about the depletion layer, second is electrical field that is set inside the depletion layer, and third, what happens to the valence electrons when an external force is applied to it. The depletion layer, we know that when a p and n type semiconductor are joined together, diffusion takes place and as a result recombination occurs, and after some time a barrier is formed which we call it as the depletion layer. That is, we do have two walls on either sides of the immobile charges. The depletion layer will hold the immobile charges, and on either sides there is a wall which the wall of the N region is positively charged as it has lost electrons, and the wall of the P region is negatively charged as it has gained electrons. And because of this, the resultant is an electric field is going to be set up as shown in the figure. So, we have known about the depletion layer, the walls, and the electric field that is going to be set up. Now, what really happens when an external source with high energy impinges on the valence electrons? what will really happen? The valence electrons would get excited, they get dislodged from the outermost orbit and they move to a higher energy state. So these are the three basic concepts that we will have in mind, which will definitely help us in understanding the working principle of the photodiode. Now we'll get into the working principle. As said earlier, we will try to analyze it with two cases. The first case we will take is when light falls on the photodiode. What happens when light falls on the photodiode?
Now we are going to discuss what happens to a photodiode when light falls on it. As you already know, the light is going to be made to fall on the active surface, that is the depletion layer. Okay, right. So this is going to be the connection. So your photodiode is going to be working only under reverse bias, or it is useful only under reverse bias, and there are immobile charges that are going to be present inside the depletion layer. We are going to understand what is going to happen to this immobile charges when light is going to impinge on this depletion layer. இப்போ நமக்கு வந்து லைட் வந்து ஒரு எனர்ஜியோட வரப்போகுது, right? And the energy is going to be given by E is equal to h nu, right? Where h is the Planck's constant and nu is the frequency of light. In the light வந்து, so it is going to have some energy. It is going to fall on this depletion layer. இப்போ இங்க இருக்கிற mobile charges we have taken only the valence electrons. இப்போ என்ன ஆக போகுது அப்படினா, when light falls on this when light hits this valence shell, it gives enough energy to the electrons in the outermost orbit, and as a result what happens, these electrons would have gained enough energy to get itself out from the outermost orbit. அப்ப என்ன ஆகும் அப்படினா, it gets dislodged and moves out from the orbit, and thus it becomes a free electron. இப்போ இந்த எலக்ட்ரான் இப்போ அந்த எலக்ட்ரான் வெளியில வந்துருச்சு, again it should not get attracted, so there should be some attracting force for this electron to move, இல்லைங்களா? அந்த attracting force எது கொடுக்கும் அப்படினா, in the wall of the depletion layer என்ன பண்ணும் அப்படினா, so it is positively it is more positive. So what happens is that these electrons are pulled towards this positive charges, and as a result these electrons move into the n region. இந்த எலக்ட்ரான் இங்க வந்ததுக்கு அப்புறம் என்ன ஆகும் அப்படினா, the reverse bias, what happens is that it will start attracting the electrons from the n region, and as a result the electron starts to move right towards this positively charged plate, and என்ன ஆகும், இது it is going to emit electrons, இல்லைங்களா? அப்ப electrons இங்க இருந்து வருது, இங்க வந்து சேருது, திருப்பி electrons இங்க இருந்து வருது, திருப்பி உள்ள போகுது, திருப்பி it happens as in a cycle, right? And what we say, when electrons move, we say that is going to be a current that is going to flow, right? So this is the phenomenon, right? அத நீங்க இங்க பாருங்க, இப்போ நாம என்ன பண்றோம் அப்படினா, இதே கான்செப்ட் இங்க பேண்ட் வச்சு எனர்ஜி பேண்ட் வச்சு நம்ம பேசுறோம். When light is going to be falling on the valence electrons, so what happens, the electrons in the valence band, right, gain enough energy, and as a result it jumps from the valence band to the conduction band and becomes free electrons. When the free electrons they are free to move, and as a result what happens is that there is a current that is going to get produced, right? So this is what really happens when light falls on a photodiode. This is case number 1. Okay?
To summarize, when light falls on the photodiode, electric current is produced. This electric current is given a name, photocurrent. The reason being, this is the current that is going to be because of the light that has fallen on the photodiode. The photocurrent that is generated is proportional to the light intensity. As the intensity of the light is increased, the photocurrent also increases, and vice versa.
Case number 2 என்ன அப்படினா, when light does not fall, அப்ப அது என்ன நடக்கும் அப்படின்றத பார்க்கலாம்.
Now we'll try to get into the second case, when light does not fall on the photodiode. We already know when a diode is reverse biased, reverse saturation current flows because of the thermally generated minority carriers. So, this makes us clear that even if light does not fall on the photodiode, there still exists a current, and this current is called as dark current. Dark current is the current that is going to flow inside the photodiode even in the absence of light, and this is all because of the thermally generated carriers, minority carriers, that are present in the photodiode. From the understanding of the working of the photodiode under two cases, the characteristic curve can be easily drawn. Dark current is a current which flows inside the photodiode even in the absence of light, and that is clearly depicted in the picture. And we could also infer that as light intensity increases, the magnitude of the current also increases. And one more point to note is that the reverse bias does not have an effect on the magnitude of the current that is going to flow. So, it is clearly visible that as light intensity is varied, the electric current also varies. So, photodiode can be used as a variable resistor. So, this is one important point that we can infer from the characteristic curve. We will try to list down a few real-time applications of photodiode. Photodiode can be used in burglar alarms. It can be used in banks to count the number of currency notes, and it can be used in malls for counting people, as well as it can be used in communication systems. First, we'll see how it can be used in burglar alarms.
We will assume that this is the entrance of a house. This is the entrance there. At one side of the wall, an infrared light source is fixed, right? Where this light falls on the photodiode continuously, right? This photodiode is fixed on the other side of the wall, other side of the entrance, right? There is an alarm circuit that is going to be connected with the photodiode, right? The alarm circuit is designed in such a way that whenever the light is broken, the path of the light is broken, this alarm is going to beep, right? So that is how this alarm circuit is designed, right? Say for example, there is an intruder who is going to come at night, or who wants to steal something from your house, right? And a burglar comes, breaks the door and enters. When he enters, automatically what he will do is, he will break the path of the light, right, falling on the photodiode, and as a result, it will activate the alarm circuit and the alarm will beep, right? So this is how your photodiode is going to be used.
It can be used in bank. Now we'll try to understand how photodiode is used in communication systems. It is mainly used in optical communication. In optical communication, the data is carried by light. The data has to be decoded at the receiver. To do that, a photodiode comes handy. It decodes the data and gives it to the destination. So this is how a photodiode is used in communication systems. Now we'll move on to the advantages of photodiode. Photodiode is very sensitive to light, highly sensitive to light, and the speed of operation is also very high. And that is why you could notice that photodiode is used in banks to count the number of currency notes in a fraction of a second. It does the work in a fraction of a second, right? Even if you give a bundle of notes to the system, it counts it very quickly. In no time it counts and gives us the answer. We'll move on to the disadvantages. It has a poor temperature sensitivity. And second thing is, the dark current increases with temperature. As you could notice, dark current is all because of thermally generated minority carriers, and we have already studied that as temperature increases, the thermally generated carriers also will increase, and so does the dark current. So dark current increases with temperature. And the third important disadvantage is that the amplification of the output is required, because the magnitude of current that is generated from the photodiode is going to be very small. So these are certain disadvantages and advantages of photodiode, and that's all. Before we draw the curtains, now we'll just have a quick summary of what we had seen. First, we saw the principle of photodiode, and we have understood that a photodiode is a two-terminal device which is going to convert light energy to electrical energy. So photodiodes are otherwise called as photodetectors or photosensors. Next, we went into the mode of operation. The important thing to ponder upon is that photodiode is going to be used or operated only in reverse bias. And we have understood the working principle under two cases. One, when light falls. When light falls on it, an electric current that is going to be produced is generated, which we call it as the photocurrent, and this photocurrent is going to be directly proportional to light intensity. And when light does not fall, there is still a small reverse current that is going to flow, reverse saturation current that is going to flow because of thermally generated carriers, and that is why this is called as dark current. Even in the absence of light, there is a small current that is going to flow. And we went into the applications of it. We understood how it is used in burglar alarms, banks, malls, and importantly in communication systems. Then we went into finding out what are the advantages and disadvantages of photodiode. With this, we come to a close.
Wish that this video had been really useful to you. If you had liked this video, please subscribe and share your comments, and do not forget to click the bell button. Thanks for watching.